Hi everyone, today I'm going to go over logistic regression using R, and as a reminder, use logistic regression when you want to predict the probability that an event occurs. And right now we're looking at the Titanic data set, and the event here is whether or not the passenger survived. So the 0 means that Mr. Braund did not survive, the 1 means that Mrs. Cummings, who was a first-class female, did survive. And these are the variables, columns B through K, that we have to predict whether or not they survived. And I created column L because we have missing data for age, and we're going to want to fill these in with actual values to help us predict survived. And the reason this makes sense, clearly Mr. is older than Master, and in general Mrs. is older than Miss, so that'll help us out. And the model that I'm going to show you will get you 333rd out of about 6,000 people in this Kaggle competition. So it's a good model. Let's go to RStudio and load the data. And the data are divided into a training and testing data set. So you estimate your model for the training data set, and then the testing data set doesn't tell us whether they survived or not. You have to make that prediction using your model. So the first thing, we're going to want to predict age, and we're just going to do a linear model using these variables to predict age. And then we're going to go through the training data set, and where age is NA, we're going to use our model to predict what it would have been. And then I created a new data set. And logistic regressions in R are run using the GLM function. And if you've never used it before, go to !GLM. And this looks intimidating at first, but you don't have to, the only thing you have to specify is formula and family. And the only difference between the GLM and LM is that you give it a family, and if you do the family equals binomial, link equals logit, that's what gives you the logistic regression model. Let's run that and look at the summary of the model. So passenger class, obviously significant in determining whether someone survived. And passenger class was encoded as 1, 2, or 3. So if you go, the negative coefficient means that as passenger class increases, the probability of you surviving decreases. And these are, the colon means an interaction term. So I put in a few interaction terms in there too. And now to make predictions based on your model, on your training data set, use the predict function. And when I first saw this, it wasn't really what I wanted. I wanted probabilities. So I went to predict.glm and realized that I wanted type equals response is what gives you the probabilities. So let's look at that. This means that the model predicted a 13% chance of survival for the first passenger, a 97% chance of survival for the second passenger. And if we remember what the data looked like, the first passenger was a third-class male, probably not going to make it, and second passenger, first-class female. So it's nice to see that your model at least makes sense, and she paid a lot of money to be on the Titanic, so nice to know that the extra fare helped her survive. Now you want to see how well your model did, and so P is just storing the predictions in a vector, and then we're going to convert those to zeros or ones, 0 meaning died, 1 meaning lived, just using round. So if the model predicted a 50% chance of survival, we would round that up to assuming that they did survive. Now using the caret package, we're going to make a confusion matrix. And this tells you that you predicted 82% of your training sample correctly. And that in general gives you an optimistic prediction rate because it's using the data that your model was trained on. And when you move to data that it hasn't seen yet, it's actually going to give you a slightly lower accuracy rate. And this means that the person died 0 and the model predicted a 0 501 times. So the 48 and 108, those are your errors. So now let's move on to making predictions on the test data set. And there are also missing values for age in the test set. We're going to do the exact same thing we did for the training data set and predict those. And then I noticed that the 153rd observation in the test data set was missing the fare. So I looked up that they were third class. So I'm going to use the mean of the third class fares to predict their fare. And this means that the average fare for a third class passenger was $13. And then one way to make predictions based on the model is to say, if the probability is less than a certain value, we're going to assign a 0. And so what you could do is you could fiddle around with this until you thought you had the best number. But I think that's kind of overfitting the data. And in the end, if it does work, it's a coincidence. So the other way to do it is to round your predictions to zeros or ones. And we haven't seen these observations yet. So the model predicted that the first passenger in the test data set died, second passenger died. And now we're going to want to write these to a file so we can upload it. Oh. And then that's all we need to do. Upload that to Kaggle, and that will get you 333rd place. And thanks for watching, and once the competition's over, I'll go over what I did to get a slightly better score. Have a nice day.